Gators, this is 11-2, volumes of prisms and cylinders, day 3. I can use the properties of prisms and cylinders to calculate volumes. Let's take a look at a more complicated prism composite, which is two prisms, one on top of each other, and let's see if we can find the volume of this total thing. So it's really made up of two prisms. We have a volume of a triangular prism, and we have the volume of a rectangle prism. It might help for you to draw the base, and for the triangular prism, the base is a triangle. So let's go ahead and draw the triangle, and we can see the base is 45 and the height is 18. So this is going to be area of the base times the height. The base is a triangle, 1/2 base times height, and these are all of the triangle, and then times the height, but this is the height of the prism. All right, and so just looking at the triangle, the base is 45. I said 46, but it's 45. So this should have been a 5. And then the height is 18. So this was 45 and the height is 18. And this is the height of the prism right here, which is 17. All right, and let me go ahead and find the answer. This is, I'm getting the answer 6,885. Okay, for the rectangular prism, let's go ahead and draw the face. I'm going to draw that front face right here, and that is 45, and then the height is 20. So it's this thing right here is, I'm considering my face, or the base. So it's the area of the base times the height, and the base is 40, that is still a 5. I'm writing, it makes it look like a 6, but it's 45 times 20. And so this is the 45, this is the 20, and then the height of the prism is 17, just like the height for the prism on the other one was 17 also. I'm going to put those numbers in, and I get 15,300. So the volume of the composite, that means both of them together, will be these two numbers added up together. And that will be 22,185, and we're talking about cubic centimeters. That's the volume. Now let's take a look at this volume of a whole cylinder. So it's a cylinder, but then another cylinder has been taken out of it. So we're going to find this volume of the big cylinder, volume of the big one, and we're going to find the volume of the small one. It's area of the base times the height, and the base is a circle. And for the big one, the radius is 8. And the height is 30. I'm going to leave this exact, so this is 64 times 30, and so this is 1,920 pi. I'm going to work with exact, it'll be a lot nicer. This is the volume of the base times the height. The base is pi r squared h, and the radius, since the whole diameter is 4, the radius will be 2, and again it's a height of 30. So this is the number 4, this will be 120 pi. Okay, so the volume of the composite, don't add the two numbers, you are going to be subtracting them. Now since I worked with it exact, it's going to be a lot nicer. And so this answer is going to be 1,800 pi. Now this is centimeters cubed. Now this is an exact answer because I haven't used my calculator. But if I wanted a rounded answer, I'd put it in the calculator, use the pi button, and that would represent 5654.9 cubic centimeters, and that is a rounded answer because I had a lot of numbers afterwards that I totally ignored. Okay, let's find the volume of a prism with a cylindrical hole. Same idea. This time we're going to find the volume of the prism minus the volume of the cylinder. And that's going to be the volume of the composite. So volume of the prism is area of the base times the height, and cylinder will be area of the base times the height, but the base is going to be a circle, so I'll just write pi r squared height. Now the base right here, I'm going to use this as my base. The area of the prism is going to be 10 times 14, and then here's the height, which is 12, minus pi, and you could see that the radius is a 2 and the height is 12. So this is going to be 101,680, and then we're going to subtract, and that's a 4, so that's 48 pi, and this is inches cubed, and this is called an exact answer. You cannot put the number with a pi. You have to leave it separately. But if you want it rounded, then we could put it in our calculator, and that would be around, and that's what I'm showing is approximately, and that would be inches cubed. Okay, be aware of what is exact and when it's not. Okay, let's figure out how many cans of pineapple juice will fit into this pitcher. So we need to know the volume of the pitcher, and we need to find the volume of the can. The volume of the pitcher, of course, is a lot bigger. So that's area of the base times the height, which is pi r squared h. The radius, let's see, it's 11 tall. This is 11 tall, and the radius right here is 4. So we're going to put a 4 here, and then an 11 here. So that's, I'm going to leave everything in exact, it might be easier, 176 pi. Now for the can, it's the area of the base times the height, which is pi r squared h, pi, and our radius of the can is 2 inches. So this is 2 squared, and the height is 6 inches right there. So that's 4 times 6, which is 24 pi. All right, to find the number of cans, we're going to take the pitcher's volume and divide it by how many cans we can get in there. And we can see the pi's are going to reduce, and 176 divided by 24 is approximately 7.333 repeating. So we would say about how many cans? About 7 cans. And we won't worry about the 0.333. Okay, so in this lesson, remember we talked about the volume of a prism, the volume of a cylinder, and the volume of a composite.